Well, let's see 27. 27 can be written as 1 times 27, 3 times 9, 3 times 3 times 3. How many factors? There are 1, 3, 9, 27. So 4 factors, okay? Which means, 27 is not a prime because 27 has more than 2 factors. And the prime factors, we can have those. So, we should remember those prime factors. 2, 3, 5, 7. 2 is the only even prime number. Right? 2, 3, 5, 7, 11, 13, 17, 19, 23. What's the next one? 29, 31, 33, 34, 35, 36, 37. Right? Then 41, so on and so forth. All right? You should try to, to find out prime numbers, from 1 to 100. So within 100. Let's see the number of 33. 33 can be written as 1 times 33, 3 times 11. Well, 1 is 1, right? 3 and 11 are prime numbers. So that means there are no more factors. So we have 1, 3, 11, 33. All right? 4 factors. 4 factors. So 33 is not a prime. 4 is not a prime, right? 4 is not a prime factor of 20 because 4 is 1 times 4 or 2 times 2. Because 4 is 2 times 2. 4 has 3 factors, 1, 2, 4. So just remember, prime factor has only 2 factors, 1 and itself. Right. 2 is the smallest prime number and also the only even prime. And the contrary to prime numbers, we call composite numbers. Right? Composite, so those ones are prime numbers. If a number is not a prime number, and we call a composite number, like 33. Right? 33 has factors of 1, 3, 11, and 33. So a composite number has more than 2 factors. That's not a prime. Composite number has factors other than 1 and the number itself. Okay, so which means it has at least 3 factors. Right? Example like 33, right? 3 factors, 1, 11, 1, 3, 11, 33. So 4 factors. So if a number is not prime, it's a composite number, right? Composite number means it has more than 2 factors. Now that's numbers, right? Easy to understand. Now let's see expressions, right? Because we talk about factors for binomials, for fractions, for expressions. Expressions means involve variables and numbers and operations. Let's see this case. We have 3x plus 6. And we call this binomial because there are 2 terms, right? 3x is 1 term. Multiplication and division like a glue, right? So 3 multiplied by x, we consider as 1 term. We consider as one thing. 6 is another term. So plus separates. Okay. So plus separates 3x and 6 as 2 terms. So how can we factor this expression? Okay. 3 is 3 times x. 6 is 3 times 2. Now we see common factor of 3. So this term has 3 as a factor. This term has 3 as a factor. So that means we can factor out common factor 3. Then we put the rest into a parenthesis. So we have x plus 2 in the parenthesis. If we use distribution law, we do 3 times x plus 3 times 2, where we get back 3x plus 6. So what do we see about 3 and x plus 2? So we say 3 is a factor of 3x plus 6. and x plus 2 is a factor of 3x plus 6. All right, so the expression 3x plus 6 has two factors, 3 and x plus 2. All right, you see it's treated, so this is a binomial, two terms called a binomial, but it's a factor of an expression. That's okay, right? So make sure we can understand this. An expression can be a factor of some other expressions. So binomial means two terms. And one term is called a monomial. All right. 3x itself is a monomial. 6 itself is a monomial. Right. 3x plus 6 is called a binomial, two terms. Nomial just, by convention means expression, all right? So we see 3 and x plus 2 are factors of 3x plus 6, right? If you want, I can always put a parenthesis around the factor. Well, let's see this one. Quadratic expression, right? X squared minus 2x plus 1. We know that's x minus 1 times x minus 1, or x minus 1 squared. So we see this expression has two factors, right? Or has one factor with multiplicity of 2. You're going to learn multiplicity later on, all right? And you just, well, for now, you can think, okay, so this expression can be factored as this. The two factors are the same, x minus 1, x minus 1. All right. If we do distribution, especially we call this a FOIL or double distribution, then we see we get back this expression. Right. So we see x minus 1 is a factor of x squared minus 2x plus 1. Anyone has any questions? All right. Okay, let's see divisibility by a number. So 6 is a multiple of 3, right? So that means 6 is divisible by 3 and by 2. 12 is a multiple of 4. That means 12 is divisible by 4. Right? 6 is divisible by 3 because when 6 is divided by 3, we get 2. 12 is divisible by 4 because 12 divided by 4, that's 3. So this is called a divisibility or divisible. Factors again, a times b equals to m. We call a and b factors of m. Right? Like a 2 times 3 is 6. So we call 2 and 3 factors of 6. Was a variable. Variable just means a symbol or a letter or any notation, as an empty container, right, represent a value. Normally we use X, Y, Z or A, B, C. Constant, so variable versus constant. Variable means it changes, right? Constant means it doesn't change. So constant is a number whose value always stays the same. If we talk about 2, right? The same number. 2 is just 2, forever 2. Half is forever half, right? It won't change. It will always be that. Example, 3x plus 1. 3x, so x is a variable, right? X is a variable. And 1 is constant, so this 1 is constant. What about this 3 in green color? We don't call 3 a constant. What do we call it? We call a coefficient or a scalar because it scales x. all right? Because it multiplies by x, so we call coefficient. Okay, so in this expression, the variable is x, the constant is 1, 3 is called a coefficient of x. All right, 3 is a coefficient of x. 3 is the coefficient of x. Okay, that's how we identify them. Operation symbols: plus, minus, division, multiplication, equality, right? When we put the equal sign. So 1 plus 2 equals 3, that becomes an equation. 3x plus 1 equals 9, that becomes an equation. Inequality, right? Greater than or equal to, less than or equal to, less than, greater than, right? So on and so forth. Let's put this one here. Right? Or not equal to, this means not equal to, right? Not equal to. Examples: 0 not equal to 1. 5 greater than or equal to 3. 3 greater than or equal to 3. Questions? I heard some sound. Anyone has any questions? Less than or equal to 3, less than or equal to 3, 3 less than or equal to 5, 3 less than 5, 5 greater than 3. Real number line. So we use this to represent the real number line. 0 sits in the middle. To the right-hand side are positive numbers. To the left-hand side are negative numbers. So we go to the right, the numbers become bigger and bigger. We go to the left, the numbers become smaller and smaller. So to the left, it goes to negative infinity. To the right, it goes to positive infinity. And we use grouping symbols, right? Parentheses, brackets, wiggly parentheses. Okay. So parentheses, brackets, braces. What about the rank? The inside one, we use this one, the second layer, then the out layer. Right. Let's see this one. So we have parentheses, we have brackets, we have braces. So when we calculate this, we follow the rank. So we do the parentheses first. So 5 plus 1 is 6. Then we do the brackets. Brackets second. 3 minus 6 minus 1. That's minus 4. We do brackets first. Then lastly, we do the braces. Right? 3 minus 4, negative 1 plus 3 equals 2. And the 1 is not inside any, has the lowest rank. So we'll calculate the last. Right? So we follow this order, follow this rank. Expression can be number, can be variable, or can be combination of numbers and variables, with operations. 1 plus 2 is an expression, 2x is an expression, 2 times 3 expression, 3x plus 1 expression. All right. Basically, any mathematical terms without equation is an expression. So equation, you see equal signs. 2 times 3 equals 4, that's an equation. 1 plus 2 equals 3, that's an equation. 3x plus 1 equals 9, that's an equation. So the world of mathematics basically have two families, right? Expressions and equations. So when we talk about expressions, we can simplify expressions, or we can evaluate expressions, right? But we can never solve expressions. You know, I heard so many students often use the term solve expressions. Never. We can never solve expressions, right? We solve equations. We can simplify and solve equations. We can simplify and evaluate expressions. Exponential notation, we have base, exponent, right? So a raised by n, a is a base, n is the exponent, or sometimes called n power. Right? So a raised by 3, or a to the power 3, is a times a times a 3 times. Right? So a is base, n, 3 in this case, 3 the exponent. 2 to the 3, I don't know why this becomes so small. 2 to the 3 equals 2 times 2 times 2, 3 times, which is 8. Simplifying expressions use order of operation, what people call pandas. Right? So parentheses first, we have 3 layers, 3 different ranks of parentheses. Then we calculate exponents, then multiplication or division. Okay, first come, first serve. Or you can think from left to right. Whoever you see first, you calculate. Let's see in this case, 12 divided by 3 multiplied by 2. Right, from left to right, you see 3 first. 12 divided by 3 first. So we need to do 12 divided by 3, that's 4. 4 times 2, that's 8. All right, this doesn't mean multiplication first. No, it means multiplication and division has the same rank. First come, first serve. Or from left to right. Add and subtract the same thing. First come, first serve, from left to right. Evaluate an expression. Right? If we're given an expression, let's say 4x minus 3y, and we want to evaluate for x equals a half, y equals 1. So we can do that, right? Then we just substitute x into half and y into y, then we calculate. And identify and combine like terms. Like terms, what does like terms mean? Like terms means it has the same variable and the variable carries the same. So like terms. When two terms are constants or have the same variable and the variable have the same variable with the same exponents, right? With the same exponent, we call it like terms. So let's see examples. If we have this trinomial means 3 terms, right? Quadratic expression. And we have this trinomial or quadratic expression. So what are like terms? We see this one is x squared, this one with x squared, so the variable is the same, x, and the exponent is the same, so those two are like terms. Then, so x squared and 2x squared are like terms. Then 3x and 5x are like terms, right? Then the constant 1 and -2 are like terms, right? So I like to, or can I make this into different color, right? So x squared and 2x squared are like terms, 3x and 5x are like terms, 1 and -2 are like terms. When they are like terms, we can combine them, right? If we add those two expressions, we can combine the like terms, or if we subtract the expression, we can combine the like terms. So what is a term? A term is a constant or product of a constant and one or more variables. Product or, has to be or, quotient. Quotient means division, right? We can multiply, we can divide. Example, 3x plus 1 has 2 terms. 3x is 1 term, 1 is 1 term. Right. Let's put this one up. So those are some examples of different terms. 3x is one term, negative 4pwq is one term, 4xy is one term, m divided by n is a term, 4m divided by 3n is one term. So you see here, multiplication and division like a glue. Okay, glue the number and the variables together as one term. Right. 3x plus 1 has two terms. Right. 3x is one term, 1 is one term. So you see addition and subtraction separates terms. Again, the coefficient. The coefficient of a term is the constant that multiplies the variable in the term, right? So 3 is the coefficient of x. And 1 is constant. So 3x plus 1, 3 is the coefficient of x. So how do we combine like terms? Before that, let's understand this. So x, by convention, that's 1x. That's 1x raised by first power. Okay, it's 1x raised by 1. Y is 1y raised by first power. Right? Negative x is negative 1x. Negative y is negative 1y. Negative ab is negative 1ab. So we just don't bother to write 1 in front. But when we calculate, so we need to understand that there's an invisible 1 there. Let's see in this case, we have 3m plus m. So 3m plus m, m means 1m. Right? M is common factor, so we can factor out the common factor m. So 3 plus 1 is 4, 4m. So 3m plus m equals 4m. Let's see this one. 6ab minus ab. Well, minus ab means minus 1ab. So 6ab minus 1ab. So 6 minus 1 is 5. So that's 5ab. What about 4xy minus 6x? It cannot be combined, right? Because 4xy and the negative 6x are not like terms. This one has y, this one doesn't have y. They're not like terms. We cannot do anything with it. But if we have this, 4xy minus 6x minus 3xy, we identify 4xy, negative 3xy are like terms, right? So 4xy minus 3xy, that's 1xy. 1xy, we just don't bother to write a 1 up front of xy. It just becomes xy. Okay, translate English phrase into algebraic expression. Addition, subtraction, multiplication, division. Let's see this. The sum of A and B. What is A plus B? Right, the sum. The difference of A and B. Okay, this is important. The order matters. Right? The difference of A and B means A minus B. The difference of B and A, that's B minus A. Okay, you see B minus A. So when we talk about difference, the order matters. The sum doesn't matter. But A plus B, B plus A are the same. The product of A and B is A multiplied by B. Right. The quotient, also the order doesn't matter. A times B equals B times A. The quotient of A and B, right? Quotient, order matters now. That's A divided by B. The quotient of B and A, that's B divided by A. So subtraction and division order matters. Let's see this example. The width of a rectangle. Okay, a rectangle. A rectangle is a, right? So this piece of paper is a rectangle, right? The opposite sides are parallel, and the angles are 90 degrees, right? Rectangle. The width of a rectangle is 14, less than the length. All right. And if W represents the width of the rectangle, write an expression for the length of the rectangle, right? 14 less than the length. So W equals to L subtract 14, because it's a 14 less than. Something has to be before then. So that's W equals to L minus 14. The width is the length subtract 14. It's not 14 subtract L. All right, be careful of that. Okay. But we want to write the length in terms of the width. So what do? That means we want to rewrite it. We add 14 on both sides. So that means the length equals the width plus 14. All right. Anyone has any questions? Let's see this example. The number of women in the statistics class is A more than twice the number of men. Let M represents the number of men. So write an expression for the number of women. Or W represents women, right? So this tells you the number of women, W, is A more than means something plus A, twice the number of men means 2M, so 2M plus 8, okay? So W equals to 2M, because twice the number of men, so just 2M, twice as much, just 2 multiplied by A more than means just add A to it. So W equals to 2M plus 8. Let's see this one. Erica has rock and country songs on his playlist. The number of rock songs is 14 more than twice the number of country songs. Letter C represents the number of country songs. Right? So twice the number of country songs will be 2C. 14 more will be just plus 14. So the rock songs, well, letter R represents the rock songs, will be 2C plus 14. Greg has nickels and pennies in his pocket. The number of pennies is 7 less than 3 times the number of nickels. So if we use n represents the number of nickels, so 3 times number of nickels is 3n, right? 7 less than, that's 3n subtract 7. Okay. So the pennies, the number of pennies we use p to represent, so p equals to 3n minus 7. Okay, oftentimes people make mistakes writing p equals 7 minus 3n. No, because 7 less than. If we don't have the then, 7 less 3 times the number of nickels, that would be 7 minus 3n. But here we have less than, okay? Less than makes it different. Okay. Let me make a note here. So 7 minus 3n means 7 less 3n, okay? No, doesn't have the word then, okay? So that's 1.1, okay, about some terms about algebra. So 1.2 talk about integers. So integers, negative versus positive numbers, right? We use negative A as the opposite of A, or better yet, we call additive inverse. Okay, so A and negative A are additive inverse with each other. Okay, additive inverse. Let me make this. Additive inverse means when we add those two, we get 0. All right. So A plus negative A equals 0. And 0 is called additive identity. 0 and 1, the two numbers are most important numbers, right? Because 0 equals some number, subtract itself, right? Or, so I can just do this, a minus a, right? A number subtract itself, or a number add its additive identity is always 0. You know, when we're completing squares, we add a 0, we add a number, then we subtract the number. You know, similarly for 1, but a 1 is multiplicative identity. So 0 is additive identity. So let's see. Evaluate negative a when a equals 2. Well, negative a is just equal to negative 2, right? What about when a is assigned a negative 2? So negative a would be negative of negative 2, would be positive 2. So be very careful when we have double negatives, right? Double negative will become positive. So double negation tends to be positive, all right? Double negation. Absolute values, right? We use this long bar, right, to indicate absolute values. Absolute values means we only consider the distance of the number from 0. It could be 0, you know, could be the number be negative, but when we put absolute value, it becomes positive. Absolute value of 0 is always 0. Absolute value of positive number, always a positive number. Absolute value of negative number becomes negative 3, all right? So when inside the absolute sign is negative, so absolute sign means negation, negative. Because negative become positive, right? But if the negative sign outside the absolute sign, it stays negative. Because the absolute value of 3 is just 3. So it's still negative 3. So be careful with this. Negative absolute value of negative 3 is also negative 3, right? Because the absolute value of negative 3 becomes positive. So it stays negative. So in general, if we absolute a negative number, that's just a negation of the negative number, become positive number. Or if the number is positive, it's just positive. Well, let's see these signs. Let's get familiar with these signs. Greater than, less than or equal to, greater than or equal to. Let's see this. You have homework, something like this. If we negate negative 13, that becomes positive 13, right? And on the other side, absolute value of negative 13 is positive 13, but negation sign is outside, that becomes negative 13. So we should put greater than sign in the middle, because 13 is greater than negative 13. And B, let's say 5, negative of absolute value of negative 5. Absolute value of negative 5 is a positive 5, negative 5. So we still get negative 5. 5 is greater, so we should put a greater sign here. 5 is greater than negative 5. Well, 0, negative 0 is always 0. You know, 0 equals 0, right? It just equals to 0. Well, let's see this one. Absolute value of an expression is always greater or equal to the expression itself, right? Think about a 2 or negative 2. Right? Negative absolute value is always less than or equal to the value itself. You can use two numbers, right? You use, let's say 2. If this is 2, negative 2 less than or equal to 2. Well, if the inside is a negative 2, you have absolute value of negative 2 becomes 2 again. Then you have this negative sign that's negative 2. Negative 2 less than or equal to negative 2. Or absolute value of a number is always greater than or equal to negation of the number. You can also use two numbers to convince yourself. So make sure you understand the logic of this. You have homework like that. Or let's see, this expression involves absolute value signs, right? Anyone? So Ajeda, you have a question? Anyone has any questions? All right, let's keep going. So inside the absolute value sign, we see parentheses. So we should always do parentheses first. So we do 6 minus 2 would be 4. Negative 3 times 4, negative 12. Right? So 3 times 4. Then that's negative 12. 19 minus 12, that's 7. Absolute value of 7 is a 7. 24 minus 7, that's 17. Right, which is just follow the order of operation. Let's see this one. Inside the absolute value sign, we have 15 minus 7, that's 8. 14 minus 6, that's 8. Absolute value of 8 is 8. Absolute value of 8 is 8. 8 minus 8, that's 0. Sign integers means it has minus sign, right? So 1, 2, 3, that's called counting numbers. 0, if we add 0 to counting numbers, that becomes whole numbers. If we add negative numbers to whole numbers, that's integers. That's a set of integers. So a minus b, we can think that's a plus negative b, right? Like 5 minus 1, we can think as 5 plus negative 1, right, equals 4. Usually we do the opposite, right? Negative 2 minus 3, that's negative 2 plus negative 3, which is negative 5. 3 minus 7, we can think that's 3 plus negative 7, which is a negative 4. 7 minus parentheses, negative 4 minus 3, well, negative 4 plus negative 3, that's negative 7. Negative 7 become positive 7. 7 plus 7, 14. 14 minus 9, 5. A minus b, we can think that's a plus negative b, or negative b plus a, or negative 1b minus negative 1a, or negative 1 times b minus a, or negative parentheses b minus a. All right, so this line is super important for you, all right? All the algebra confusing part sometimes is included in this one line. They are all the same. It depends on which one will be needed. That's okay. Don't worry about it. Yeah, Ajeda, don't worry about it. I thought you have a question. That's okay. All right. So make sure you understand this line. All right. Make sure you understand this line. They equal to each other. All right. So sometimes it becomes confusing. Convince yourself this line makes sense. A minus b is a negative of b minus a. All right. Make sure you see this. You see, if we distribute negative sign inside, we get negative b. Right. That's negative b. Negative a, that become positive a. So those two are the same. A minus b plus b minus a equals 0. Use the numbers 5 minus 3 equals negative 3 minus 5. You see negative 2 is positive 2. Right, this example, negative 1 minus 1, negative 6 minus 1, that's negative of 1 minus negative 6. Right. which is -7. Just try to convince yourself with these examples. 3 plus 4, that's 7. That's 3 minus -4. That's -1 times -3 minus 3. These are the examples to show you this line, all right? Multiple and divide sign numbers divided by negative numbers. Positive, positive equals positive. Negative, negative equals positive. Positive, negative equals negative. Negative, positive equals negative. Right? Positive divides by positive, still positive. Positive divides by negative, negative. Negative divided by negative, positive. Negative divided by positive, negative. Some examples. Negative divided by negative, positive. But be careful with this, right? This is a -4 squared. This square has nothing to do with the negative sign. So 4 squared is 16, so we get -16. But with this one, we have parentheses around -4. If we have parentheses around -4, that's -4 times -4. So that 2 has, the square is on the negative sign also. So we get +16. -2 with parentheses square, that's +4. -2 cube, that's -8, because the exponent is odd. Right? When the exponent of a negative number, it becomes positive. But exponent is odd, the odd exponent of a negative number stays negative number. This doesn't come down. Okay. So x positive, y negative. Positive divided by negative will be negative. When negative divided by negative will be positive. Let's see this one. Positive times negative will be negative. Negative divided by negative will be positive. Negative divided by positive will be negative. Negative times negative will be positive. Well, let's see, evaluate. Let's see, this will have a trinomial, 3 terms, right? We want to evaluate when x equals 2, y equals -1. Oh, we just substitute x into, we substitute y into -1. So 4 times 2 minus 2 times 2 times -1 square plus 3 times -1 cube. 4 times 2 is 8. -2 times 2, -4. Then times -1 square is 1. -1 cube is -1. -1 times 3, that's -3. And then add them up, get a 1. Applications. On January 21, the high temperature in Palm Springs, California was 89 degrees. And the high temperature in Whitefield, New Hampshire was -31 degrees. What was the difference between the temperature in Palm Springs and Whitefield? So Palm Springs is 89. Difference means subtract, right? Then White Plains is -31. So we'll have 89 minus -31. That becomes 89 plus 31, which is 120. So the difference is 120. On the first down, the Steelers had the ball on the 30-yard line. On the next 3 downs, they gained 9 yards. Lost 14. Lost, subtract, right? Gain means add. Lost 2 yards again, subtract. So what do we have? We have 30 plus 9 minus 14 minus 2. Right, 30 plus 9, 39. -14 minus 2, that's -16. So subtract, we get 23. And that's it for today. Very simple. Anyone has any questions?
Hi, Professor. You gonna be available to look over, right?
Yeah.
I missed the first part of the class. I had
Yeah.
connectivity issues.
Okay. Then you can go back to watch the whole thing. Let me show you where it is. Let me stop recording this.